because some of the students are they are in their home. Okay, they might not come. Those who come from far, right? Because if it rains, then it's they will get stuck there. No, so they are in their home, so that is safe for them. So no attendance today. Write down the topic here. All of you write down the topic name here. So last week, okay, we already discussed the introduction of circular motion, right? Anyone who missed that class? Yeah, have you watched the recording? Even watch after watching. It's okay. So let's start the topic here. Right hand rule. Write down the topic's name, everyone. See, last class we discussed about the introduction, no, right? So then we saw what angular velocity is, right? And what is angular acceleration? One minute. Is the sound not clear, right, from the speaker? Is it clear? My voice clear? Fine. Okay, so listen here. Last class we were discussing something. Could everybody understand what was taught in the last class? Once again, I cannot teach the whole thing, but I can give you the summary. Fine. Okay. So if I'm going fast, then you can tell to slow down. Okay. Listen, everyone. Okay. If you feel that I'm fast, then you can honestly, without hesitation, right? You can just tell me. Okay. So in the last class, we were discussing about circular motion, right? So can you tell me what is angular velocity? Yeah, it is the rate of angular displacement, right? What's the other name of angular velocity? Yeah, it's denoted by omega. Can you tell me the other name of angular velocity? What is it also called? It's also called as the angular frequency. Okay, note it down. Keep this in mind, right? So can you now tell me, right, is angular velocity here, last bench, is it a vector or a scalar? What do you think? Angular velocity. What do you think? Is it a vector or a scalar? There. It's a vector. Okay. So here write down the right hand rule today. Write the first point. Write the first point. Write down angular velocity. Okay. First write down angular displacement. Write down angular displacement, comma. Write down angular displacement, comma, angular velocity and angular displacement, angular velocity and angular acceleration are vector quantities. Are vector quantities. Okay. Are vector quantities. Right. So they must have a direction, no? So write the next line. So their direction is given by the direction of these vectors. Okay, their direction is given by the right hand rule. Their direction is given, okay, by the right hand rule. Okay, the right hand rule. Fine. So now look at this diagram here. There's a mass going, okay, around a circle this way. Fine. So is there any angular velocity here? Yes or no? Since it's, yeah, covering displacement, so it's covering angle, there is an angular velocity here, right? So the direction is given by right hand rule. So how to get the direction? So you need to curl your fingers. See, listen here. Curl your fingers, okay, around the circle. Okay. So have you done this before in the first chapter? cross product of vectors, right? So you need to curl your fingers, okay, in around the circle in the direction of the object's movement. So thumb will point in the direction of the angular velocity. So in this case, thumb is pointing out. So the angular velocity here, okay, it has a direction. It's outward, something like this. Okay, it points out. So it's omega. Right. So note it down. Yes. It's going in a circle, no? So curl your fingers, okay, around the circle. So thumb is pointing out. So that is the angular velocity's direction. Okay, omega. Right. So it's if this is the circle here, no. So omega is outwards if the object is right going this way. If it's going this way, right, then this is omega. Okay, this vector coming towards you. Okay, we cannot show it here in 2D. You can use that. For something coming out, you can use dot, or for something going on, you can use cross. Right? So this is omega. So what if it goes the other way? Yeah, then it will be into the plane. Understood? Got it? So if it's going that way, what direction is this? Clockwise or anti-clockwise? This. This is anti-clockwise. Right. So if it's going, okay, if the object is moving anti-clockwise, right, then use right hand rule. Right. So omega is out of the plane, no. Right. But if it moves clockwise, it should be into the plane. It's the opposite of that. Got it? Now curl your fingers, no, around the circumference like this. So thumb is what? Outwards. If it goes the other way, right, so it should be inwards. So write down, this is anti-clockwise. Right. So omega is write down. Omega is 1. Okay, write it down. Everyone write it down. That that direction is object's direction, not angular velocity. Angular velocity is given by right hand. That is tangential speed. This is angular. These are different. I will explain this sometime. First note it. So you also have, now listen here, everyone, look at the board, now listen here. You also have velocity, right, which is tangent to the circle at every point. Okay. So this velocity has a direction which is tangent to the circle. But this is not our angular velocity. It's the tangential speed. Right? So don't get confused with this here, okay? So this and this are different things. Okay? So that you are talking about tangential speed. Its direction is always tangent to the circle. But here we are talking about omega. It's perpendicular to the plane. So and it's given by right hand rule. It's perpendicular to the out of the plane and perpendicular to that. Out of the plane, no, and perpendicular to the plane. Got it? Any doubt? You can see it's at 90 degree, right? 90 degree. This one. It may change, may not change. Depends on what kind of circular motion you have. We'll get there in today's class. Angular velocity and angular displacement. Angular velocity and angular displacement. This one is tangential speed. Okay, something which is pointing out. That is angular speed. Angular. Okay, if you have angular velocity, angular acceleration, no, or angular displacement. Okay, they always point out of the plane, and always perpendicular to the plane. Yes. How can angular velocity have the direction? It has only two direction. It can only be outwards or inwards. We say outwards when it's going anti-clockwise. If it's clockwise, it's inwards. So this is defined in this way. So it has no other direction. Yes. How angle has a? Angle is not having a velocity. The object is having a velocity. You got all thing messed up there. Okay. See here. Write a point next. Okay, write a point. Write down angular displacement. Everyone write down. Angular displacement, angular velocity. Yeah, no, theta is angular displacement, omega is angular velocity. Got it? Write down angular displacement, angular velocity, and angular acceleration. And angular acceleration can have only two directions. Can have only two directions. No, one is write down. One is out of the plane. The other is one is out of the plane. Okay, the other is into the plane. Got it? It can have no other direction apart from these two. One is out of the plane, the other is into the plane. Right, next point. When the object, write down. When the object, start writing here. When the object goes anti-clockwise. When the object goes anti-clockwise, right? When the object goes anti-clockwise, then yes. Next line. When the object goes anti-clockwise, right? Then the direction of angular velocity is, yeah, then the direction of angular velocity is, can you tell me what's the direction? When it's anti-clockwise, see here. Yeah, outwards, right? Then it's out of the plane. Then it's out of the plane. Okay. When the, next line, when the object goes clockwise, okay, when the object goes clockwise, it's, write down, it's into the plane. Into the plane. Right. So here this directions is just telling you whether the object is moving clockwise or anti-clockwise. Okay. If you see angular velocity pointing outwards, right, you can understand the object is going anti-clockwise. Got it? If you see angular velocity pointed inwards, right, then you can understand the object is going clockwise. Clear? If it's into, no, yeah, then it's going clockwise. Okay. So see here, understand the direction in which the object is moving, okay, will not be given. You can understand that from these vectors, whether it's into or out. From there you can get an idea. Understood? Okay. So we are here right hand rule, right? So you can use this for not just angular velocity, but for angular displacement and angular acceleration. If angular acceleration is present, you can find its direction from right hand rule. If it's not present, in which case angular acceleration will not be present. Second bench here. Did you hear what I was asking? What was I asking? No, just now what I was asking. You are not listening, no? Listen, listen to what I mean. You have the potential, no? You should listen to the class, right? You can do good. I know like your potential, right? But you have to listen in the class. Here, Harihara also not listening. You can now answer. Harihara, what was I asking? You can tell. Yes, Harihara. There is another one. Harihara. Can you tell me, right, in which case I was asking, in which case there is no angular acceleration. When is alpha 0? Yeah, I'm asking when is alpha 0? Good. When omega is constant. That's the easy answer. Right. So this was all about right hand rule, right? If omega is not constant, okay, if omega is not 0, change in omega, if it's not 0, right, that means omega is not constant. So then there is an angular acceleration. If omega changes, let's say 2 radians per second, after some time it's 10 radians per second. So there is a change in omega, right? So there is a presence of angular acceleration. So in that case, you can also find the direction of angular acceleration from the same rule, right hand rule. Yeah, it's always the same for all three of these. Got it? So use the right hand rule for all three of these. So let's, okay, look at the next topic here. Write down the next topic. Yes. When there will be no angular velocity. Can anyone answer? When the object is not moving at all, just there. Yeah, if displacement is 0, then no angular velocity. Okay, see. Okay, now everyone, look at the board now. See here. Okay, we have a right object moving around the circle, right? You can see the speed here. Okay, is it constant or not? Yeah, it's 10, 10 here, right? Everywhere it's 10, right? So we can say here. You are right, but here we are talking about speed, not velocity. Now, speed can be constant. Got it? So you can see here speed is constant. Okay. So if speed is constant, okay, such an circular motion is called uniform. Okay, write it down. Uniform. Okay, circular motion. Clear? Fine. If the speed is constant, if it's 10, 10, everywhere 10, then it's uniform circular motion. Got it? If the speed changes from 10, if it goes to 15 or 20, right? Yeah, then you know it's non-uniform. So let's first discuss uniform circular motion. Okay, in a uniform circular motion, right? What can you say about the speed of the object? Yeah, here we are talking about. Okay, we are talking about tangential speed. Okay, tangential or linear speed, same thing. So is the tangential speed changing here? Right, it's not changing. So we can say that the tangential speed is constant, right? So we can say it's a constant because it's not changing. Okay, what can you say about the tangential velocity then? Is the Sanjit? Now your doubt will be clear. So is the tangential velocity also constant? But you can see it's 10, 10. Good. Here it's north, right? Here it's west. So direction is changing at every instant. And we know velocity is a vector. Even if its direction changes, no, the velocity changes. So the tangential velocity is not a constant. It's not a constant. So write it down. So the next thing we have here, everyone. See here, the next thing we have here is tangential acceleration, okay? And tangential acceleration, note it down everyone, right here. Keep this in mind that tangential acceleration, right, is the change in tangential speed by time, not the velocity. So it's tangential. It's defined in this way, it's tangential speed by time. So it's dv by dt Because if you take velocity, that is already accounted by centripetal acceleration, no? So we are not taking direction here. We are just taking the speed. Fine. So it's tangential speed by time. Got it? So can you tell me tangential speed? That's what you need to keep in mind. So you may mistakenly write it as velocity, but it's not velocity, it's speed. Okay. So can you tell me here, right, whether the tangential acceleration is constant? Here, is it constant? Is it zero? It's it's change in tangential speed by time. Right. So is the tangential speed changing? No, right? So will there be any change? No. So it's zero. So it's zero by time, right? So it's zero. Okay, it's zero for uniform circular motion, but non-zero for non-uniform circular motion. Okay. There, last second bench. Samiksha, start writing, not talking. Sorry, I always get confused. She is swastika, no? One more thing here is centripetal, right? Centripetal, yes. So, one last thing here, centripetal acceleration. What can you say about that? Is it a constant? Can you show me, like, where is the centripetal acceleration here? In which direction the centripetal acceleration point? Aditya, are you listening to what I'm saying here? There, last bench, Navin, what's going on? Listen now. Tell me which direction centripetal acceleration is pointing here. We know centripetal acceleration always points towards the center of the circle, no? So at this instant, it's this way, right? At this instant, it's this way. At any other instant, it may be that way, okay? So it always points towards the center. So that means, is the centripetal acceleration here, right? Is it a constant or not? Yes or no? What do you think? So here it's this way, here it's down, and we know it's a vector. Its direction is changing at every instant, no? So how can it be a constant if it's direction? Tangential acceleration. The tangential velocity is not a constant. It's because its direction is changing at every instant. The same with centripetal acceleration. It's not a constant. It's not a constant because, see, it's pointed west here. Now it's south. Now it's northeast. So at every instant, right, the direction is changing. Right? Since these are all vectors, if the direction change, they change. So it's not a constant. Here also the same thing. Tangential velocity. But here we are taking speed now. That's why. Because here we are taking velocity into consideration. So there we are not taking. Centripetal acceleration is already taking direction into account. Then why should we again consider in tangential speed? Tangential acceleration. Got it? Got it? 10, 10. So you might be like having a doubt here. So here it's not, here is west. So why is this 0? Right? Because the direction is changing. That doubt, right? That would be true if this would have been velocity. But this is not velocity, it's speed. Speed has no direction. 10 here and 10 here is the same thing. So it's just 0 difference. Okay. But if it's a velocity, then this 10 and this 10, it's not 0. See, everyone listen here, what's going there? See, slightly confusing for some. Just listen, otherwise you will always be confused. So that's why listen now. Once again, I am explaining this. See, what's the confusing thing here is, it's between speed and velocity, okay? Speed is a scalar, it has no direction. The speed here 10, the speed here 10 are the same thing. If you take the difference, you will get 0. But the velocity here and velocity here are not the same thing because of change in direction. So if you take the difference of velocities here, it's not 0. It's 0 for speed only. Okay, so tangential acceleration is defined in such a way. We have taken tangential speed, right? So if tangential speed is zero, change in tangential speed is zero. So tangential acceleration is zero. Are you now understanding? Yeah, but here we have other acceleration, no? So centripetal acceleration is already taking that direction into account. So we are not using it there in tangential acceleration. Are you getting it? Acceleration can also be change in speed by time. It's not always change in velocity by time. Got it? So this is a misconception. It's also change in speed by time. See, centripetal acceleration is what it's keeping the object in the circle. Okay, and it's always directed towards the center. So it's changing at every instant. So here you can see it's west, south, northeast. Got it? So it's not a constant because it's changing at every instant. Centripetal acceleration can never be a constant. It always changes, right? So how can it ever be a constant? Where? Centripetal acceleration. Last class, what did we get as centripetal acceleration? Did you revise the notes? Forgot it. You did. Yeah. What was this? S is, yeah, it's V square by R, right? It's not V by delta V by T. It's V square by R. Got it? Fine. So let's move on to, okay, the next part here. It's not there. I said no. Yes, R is the radius. Okay. So here, look at the board, everybody. Right? Can you tell me whether this is a uniform circular motion or a non-uniform circular? You can see the speed changing, right? So this is a non-uniform. Write it down. Circular motion. Okay. So now let's list down these things again. Let's start with tangential speed. Here, Arvind. So Arvind, right in front of me, you are talking and turning sideways here and there. Then let's start with you. Okay. So you tell me, is the tangential speed here constant or not? You can see it's 10 here, then 20 there. It's changing, right? From 10 it's 20 now. So how can it be a constant if it's changing? So it's not a constant now. Right? So what about tangential velocity? So in a circular motion, can tangential velocity ever be a constant? Can it ever be a constant? It can never be a constant because the direction always changes. So it's always not a constant. It can never be a constant. So it's not a constant. Right. What about okay tangential acceleration? We know tangential acceleration is change in tangential speed by time, right? Is there any change in tangential speed here? Yeah, it's a change of 10, right? So tangential acceleration here, is it zero? No, so it's non-zero now. It's not zero now. Okay. So what else we have here? We have one more thing here. Yes, centripetal acceleration. So can you tell me, can centripetal acceleration ever be a constant? It always keeps changing its direction. So how can it be a constant? So it's not a constant. So write down, it's not a constant. Right. So these are the things, okay, you should know about uniform and non-uniform circular motion, right? Clear here? Understood? Mathangi understood this topic, clear, no? Right. If I ask you something about non-uniform, right, whether tangential acceleration is constant or not, you can answer it, right? Okay, now everyone note it down. Note it. Note it down. Where is your notes? Where is the circle? This thing you have to make. Draw it in your notes. Now you think you might know this, no. But after some months, you will forget this. Everyone note it down. Rosna Sai, note it down. Here. Note it down, everybody. Draw these circles. Tangential, what? Formula of velocity. Tangential velocity. It's displacement by time. Okay, and tangential speed is distance by time. That's the difference. Okay, so next topic here. Write down. Okay. Take some more time, beat fast. No talking here. Are you noting down or just here for talking? Any doubt? Clear? How was your test? This advance. Okay. How about you? How was the physics this time? You had school exams. So how many of you wrote the test? Did you write? You couldn't. You could write. How was the test this time? Very tough, you can say. Is it proper JEE advanced level this time? Because last time it was slightly less than JEE advanced level. Right. So as of now, right, you haven't yet received that proper JEE advanced level. It's actually if it's very difficult, then it's proper JEE advanced level. More negative mark. So that's where you need to this practice. I mean, you need to keep in mind these things. In JEE, you cannot do this mistake. Let's discuss later. For non-uniform motion, whether it's uniform, non-uniform, it's v square by r. At that moment, whatever v. So today you will do questions, there you will know. If it's here, then that v. Okay, write down the topic here, not talking now. So, see, today there is very less strength, but still the noise is like the other classes. So today you guys are like talking more than other you talk. Yes, you know this thing. We have formula for. Yes, we have those three equations. Yeah, and yeah, you know this. You know, you have studied somewhere, right? Okay. So do you know the three equations of motion? All of you here know. Can you tell me what's the first equation there? Advik Prakash. Who is Advik Prakash? I know. What's your name? Aditya. Ashwin. Who is Sai Aditya? You are Sayadit. Okay. Because you are not active, right? So I always get confused there. So you keep asking doubts in the class so that I know you. Okay. So you know the first equation of motion. What's the first equation of motion? V equal to, yeah, u plus 8. Can you write this? Okay. Can you write this in the angular form? Like what will V then be? Yeah, it will then be omega final. U will then be omega initial. A will then be alpha. Then time. Okay. You said you watched the recording. I don't think you watched. You don't know what alpha is. Alpha is angular acceleration. Yes, I said no talking from where the noise is coming. Who is the one talking? There, last bench. Noise is coming from there. Okay, so don't talk this much. Listen to the class. Sit there in your place. What will tell? What's the? See, angular acceleration is the change of angular velocity by time. Tangential acceleration is the change of tangential speed by time. Okay, so you have to revise your notes. Once is not enough. 2-3 times. Be clear with this. So we know the second equation is what? S equal to ut plus, yeah, half of at square, right? So can you replace this equation with angular equation? Yeah. What will displacement be? Good. Theta. So what will u be? Good. Omega initial. Time is time everywhere, right? And half of alpha t square. Right? So let's write the third equation now. Can you now write the third equation? It's what? Omega final square equal to omega initial square plus 2 alpha into theta now. Okay. Okay. Note down these equations, everybody. And now write down the conditions for these equations. Okay. First note this down. Any doubt here, anyone? Could everyone understood this? Clear to everybody there? They've understood this. So now write down the condition. You, Nideswaran. Where's your cap? Today no cap. But you are looking good without cap. Yeah. So write down the conditions. So let's write down the conditions. Okay, write down the first condition here. The first condition. When are these equations valid? Are they valid anytime, anywhere? Yeah, good. So write the first condition. The motion should be, write down. The motion should be circular motion. Okay, the motion should be circular motion. Got it? Because it's not valid in a straight line motion. Okay. The motion should be a circular motion. So it's very obvious, no? It's a circular motion. Anyone with eyes and ears, they know it should be circular motion. What? Yeah, the second equation which you are talking about. Write down the second condition. Okay, the first condition is the motion should be a circular motion. Right? The second condition is, yeah, anyone here who can tell me what the second condition is? Yeah, write down angular acceleration or alpha. Write down alpha is constant. Got it? Uniform is the other word of constant. Got it? Same word. You can also say alpha is uniform. It's the same thing. So why is alpha constant here? You can see only one alpha everywhere, but two omega. Right? So that means alpha should have just one value in this equation to use these equations. Got it? So what if alpha is variable? Can we not solve such questions in physics? Good. We can solve using integration like we have done before. We have done that in straight line, you remember. So alpha can change with time, alpha can change with angular velocity, right? The same thing, those same things. But here we won't discuss those. You have to do it on your now, because you already know what to do now. Alpha is not tangential, it's angular acceleration. See, there are three accelerations here, right? Don't get confused. Three accelerations: angular acceleration, tangential acceleration, and centripetal acceleration. So you are getting confused here in these three. You have to revise your notes like again and again for this confusion to. Alpha is how much like angular velocity is changing, how fast it's rotating. If it's rotating very fast, if you turn on a fan, right, there is some alpha. It picks up the speed. Okay, in that time there is some alpha. Okay, tangential speed is about that speed tangent to the circle, right? If that speed changes tangent to the circle, then there is tangential acceleration. Got it? And centripetal acceleration is about that acceleration towards the center. It's always there. Without it, there is no circular motion. It's the identity of a circular motion. Got it? So alpha can be zero, tangential acceleration can be zero, but centripetal acceleration can never be zero. If it's zero, then it's not a circular motion. Then it will just escape away. Okay. Write a question here, everyone. Write down. Yes. A disk. 1 minute. Yeah. Write down. A disk starts rotating. Right. Yeah. A disk starts rotating. Write down, everyone. A disk starts rotating from rest. A disk starts rotating from rest with an angular acceleration of. A disk starts rotating from rest with an angular acceleration of. Okay, with an angular acceleration of. Okay, 2 radians per second square. 2 radians per second square. 2 radians per second square. Next line. Next line is when the final angular velocity is, or you can just write when the angular velocity is, okay, 10 radians per second. Okay, when the angular velocity is 10 radians per second. Yeah, when the angular acceleration is 10 radians per second, find the number of revolutions completed by the object. Find the number of revolutions completed by the object. Can you do this? After that, what I said. Okay, next is when the angular velocity is 10 radians per second. Yeah, find the number of revolutions completed by the object. 5. What about others? Is it 5? So everybody do this. Tell me the answer there. Navin. Here, next to Navin. Sai Aditya. Next to Sai Aditya. Yeah, what next to you? What's your name? Vishnu. Good. Next to you two look identical, Vishnu and next to you. Yeah, somewhere somewhat, not entirely, somewhat identical. Vishnu, then next to you, Rohit. Yes, tell. Yeah, what were you asking? Has anyone got the answer here? Anyone else? Is it 5? What about you, Darshan? How much are you? What about you? 25. Which equation can we use here? First, second, or the third? Good. Third one, because time is not given, not asked. So use the third one. So what is omega final, Rohit? What is omega final in this question? Is it given in the question? Yes. Good, 10. Right. It's 10. So it's 10 square, right? What is omega initial in this question? It started from rest, so it's 0. 0 square plus, right? Alpha is given as 2 radians per second square, right? Then you can find what theta is. So here you will have radian square by second square. So it's 100 equal to, right, 4 theta, no? So theta is equal to 25 radians. But the question didn't ask you to find theta. It asked you the number of revolutions. Then how can you find the number of revolutions if you have theta? Can you tell me the number of revolutions n? N is the number of revolutions. So no, we know in one revolution the angle covered is 2 pi, right? So 25 radians must be what? 25 radians by 2 pi. No? This much revolutions, okay? If this was 2 pi, okay, then you would have got one revolution. 2 pi by 2 pi is 1. Clear why we divide it? To understand this, okay, see, to understand this, don't need to think much. Just think theta is 2 pi. Okay, put 2 pi there and divide by 2 pi. You get 1. So we know when theta is 2 pi, it's 1 revolution. So this formula is correct. Understood? Clear? Is time given? Is time asked? Then why will you use that? Time is not given in the question. It's not asked also. Then why will you use that equation where there is time? So you shouldn't use this equation. That's why we are using the third one. Clear? Is there any confusion? Last step. Clear? See, if theta was 4 pi, we know it's 2 revolutions. So put 4 pi here. 4 pi by 2 pi is 2. So that means this is correct. So whatever theta we have to divide by 2 pi to get number of revolutions. Let's say theta is 2 pi, okay. Here, 25 by 2 is how much? 12 point. Yeah, so it's 12.5 by pi number of revolutions. So will n have a unit? N. Will it have a unit? Number of revolution, does it have a unit? No unit. Right. So that means here also we have radians. So it got cancelled out. So no unit. Yes. Good. 3 point something. 3 point? 3.9. Yeah, around 3.9 revolution. Fine. Okay, write down the next topic here. Okay. So there are a lot of questions like this in your VDP.